Hello, students. We're going to be working on solving compound inequalities today. And I thought we would review first by solving a basic simple inequality. So you'll see, first of all, we need to remove our parentheses. We'll do the distributive property. So that would be 2x minus 14 is less than or equal to 3x minus 5. And then we will I like to get the x's on one side first, so I'm going to move mine over to the left. I think that's a good move to make when you're solving inequalities. So 2x minus 3x, that's going to give us negative 1x. Then we'll bring down the minus 14 is less than or equal to, our 3x's will cancel, and we'll have negative 5. Now we need to get this 14 moved to the other side of the inequality. So we will add 14 to both sides of the inequality, add 14, and that'll cancel the 14s. We'll have negative 1x is less than or equal to, and then negative 5 plus 14 will combine to be 9. Now, right here, I need to remember from earlier lessons, I'm getting ready to undo multiplying with dividing. When you divide by an inequality, or when there is an inequality, then you have to remember that if you divide by a negative, as we're getting ready to do now, that you will need to reverse the inequality. So this is going to need to be reversed. So I'm out of space. I'm going to go ahead and write my answer. So I'll have x is greater than or equal to, and then 9 divided by negative 1 will be negative 9. And then in your directions, it says to circle all the possible solutions. So we have to think about this is greater than or equal to. So is 5 greater than or equal to negative 9? And yes, it is. Negative 13 is not. Negative 13 is actually less than negative 9. Is negative 2 greater than or equal to negative 9? Yes, so we want to circle that one. Is 0? Yes, 0 is greater than or equal to negative 9. And then here's really the big test. Is negative 9 greater than or equal to negative 9? And yes, it is. It is equal to. So those would be our 4 answers of the answer choices given. That would be greater than or equal to negative 9. So we will move on and take a look at our actual lesson for today, which is compound inequalities. And you'll see with compound inequalities that we have 2 options. One option is when the word or is used, and another option is when the word and is used. So we'll go over these one at a time. So I'm going to start with or. With or inequalities, you usually have 2 branches of it, and or inequalities will be true if at least one of the inequalities is true. And so this is what we call a union of 2 sets. So you'll see here I have x is less than or equal to negative 3. Numbers like negative 4, negative 5, negative 6, those are all less than or equal to. Notice I have a solid dot on the negative 3. That means the negative 3 is a solution to that portion of the graph. Negative 3 is less than or equal to negative 3. And then we have the word or, and then we have another part of this statement that x is greater than 2. So numbers like 3, 4, 5, numbers that are greater than 2, but notice that the 2 has an open circle. So we've talked about this before, the 2 is not included. So 2 is not greater than 2, we would have an open circle. But this statement taken together, that x is less than or equal to negative 3 or x is greater than 2, That is what we call a compound inequality, or meaning that at least one portion of the inequality is true. And you will always see the word or when you have those kinds of inequalities. Now, I'm going to switch and have us concentrate on and inequalities. So with and inequalities, these are only true if both parts of the inequality are true. So you'll notice here we have x is greater than or equal to 2 and x is less than or equal to 4. So let's just think about what numbers would make that true. 2 would be greater than or equal to 2, and 2 is less than or equal to 4. So 2 would be a solution. 3 would be greater than or equal to 2, and 3 is less than or equal to 4. So 3 would be a solution. 4 would be a solution. 4 is greater than or equal to 2. 4 is less than or equal to 4. So those numbers we could also think about 2.5, 3.5, 3.75, 2.25, all of those numbers that are in between 2 and 4, including 2 and 4, are solutions to this. But any numbers bigger than 4 or smaller than 2 will not, like 5. 5 is not less than or equal to 4, even though 5 is bigger than 2. 0. 0 is not bigger than 2, even though 0 is less than or equal to 4. So the numbers that we include have to make both parts of this true. And so we have a shortcut way of writing this where you can see your variable in between your two inequalities. And we're going to talk in a little bit about how to write it like this. But basically, I like to think of this as x is in between and including the 2 and the 4. This is what we call an and inequality. So we have a few examples to look at where you will be, first of all, writing and graphing, and then secondly, solving and graphing compound inequalities. So we'll go with the or example first. And it says W is less than 4. I'm going to fill that in this first blank. W is less than 4. Or, and then it says W is greater than or equal to. So W greater than or equal to 9. So when we graph that, we want to remember the less than would be an open circle, an open dot. The greater than or equal to is going to be a solid dot. And so we've got our 4. We'll go here first and open dot on the 4. Less than. So we want to choose numbers that are smaller than 4. That's going to be over here to the left. Things like 3, 2, 1, 0, and into all the negatives. And then we have W is greater than or equal to 9. So on the 9, we'll have a solid dot, and then greater than or equal to. So 10, 11, 12, all of those numbers that are greater than 9. And this would be the graph and the solution for this statement. I want to switch to our second example where we're doing and. So it says -5 is less than or equal to C. -5 less than or equal to C. And 7 is greater than C. 7 is greater than C. Now, when we have and inequalities, we will rewrite them into a combined statement. And make sure that you pay attention right here. I'm going to erase that. Whoops. Our our rule is that we will always use the less than symbols. We will never use the greater than or the greater than or equal to symbols when we're writing it in this shortcut form. So we'll always look here for our smaller of the two numbers. That'd be -5. So we'll write the -5 first. Since the -5 has the less than or equal to, this is the variable I'm going to use. And then our variable, which is a C, and then our larger number, 7, will go in this blank, and I had a not an equal to bar, so I want to choose this one. And so this statement is equivalent to -5 is less than or equal to C, which is less than 7. And then graphing that, we'll have a solid dot for the -5 and an open circle on the 7. So solid on -5, open on 7, and this C is trapped in the middle of the -5 and the 7. So you'll want to shade, trapping all those numbers in the middle that are solutions. So a good one to choose is 0. Is 0 making these statements true? So is -5 less than or equal to 0? Yes. Is 7 greater than 0? Yes. If you say yes to both the parts, then you've got the right section shaded. So there's your example for and. So I've got now some problems where we're going to be solving and graphing. So we will look at this first problem, y -3 is greater than or equal to -8, and y -3 is less than or equal to 1. I want to add 3. I want to do the opposite. I want to do this to both sides of the inequality. We're going to solve one inequality at a time. My 3's will cancel. I'll have y is greater than or equal to, and then -8 plus 3 is -5. Then I have another inequality right here. So treating it separately from what I did, I have -3, so I will add 3 to both sides of my inequality, and those will cancel. That will give me y is less than or equal to, and then -1 plus 3 is 2. And since this was an and inequality, I want to write it in that shortcut form, putting my smaller number first, so -5, and then I have an equal to bar. So remember, we only use the less than or equal to's. Notice that it's pointing to the -5, just like this one is. Then we put our variable, and then now we want to point to the variable, and it also was less than or equal to, and then our larger number, a 2. So just make sure your arrows are still pointing to the same thing that they were in their individual pieces. And so both of these are going to be solid dots. We have a solid dot on the -5. We have a solid dot on the 2. And the y is trapped between the -5 and the 2. So a good number to check would be 0. Is 0 greater than or equal to -5? Yes. Is 0 less than or equal to 2? Yes. Since we answered yes to both, we have the right section shaded. Now we'll compare how we worked with this problem to what we do here. This one doesn't have the word and or in it, but it is written in the shortcut form that I have right here. So when that is the case, then we have to think about this as having 3 sections. So you have a section separated by the inequality sign. So we have section 1, section 2 here in the middle, and section 3. This middle section, your goal is to get the x by itself. So we have add 2. We want to do the opposite. We want to subtract 2 from all the sections. So normally I just subtract 2 from what I would say each side of the inequality. But I have 2 inequalities, so I have to subtract 2 from all 3 sections. And so -1 subtract 2, that will give me -3 is less than. Notice that my 2's cancel. I just have x in the middle, and then less than or equal to, and then 5 minus 2, which is 3. So notice that I have just x by itself in the middle, and it's already in this nice shortcut form that I had to work to write in example 1. So for -3, I have an open circle since I do not have the equal to bar. For the +3, I have a solid dot since I have the equal to bar. And then the x's are trapped in the middle of -3 and 3, a good number to check, 0. So if I put 0 in for x, 0 plus 2 gives me 2. Is -1 less than 2? Yes. And then 0 plus 2 gives me 2. Is 2 less than 5? Yes. And so I've got that correct solution in place. I'm going to move us on to examples 3 and 4. For these, we will be solving OR problems. So for OR problems, we will work with each individual inequality separately, and then graph them on one number line. So here I have -4. I would solve that by adding 4 to both sides of the inequality. And so the 4 would cancel. I have m is less than or equal to, and then -6 plus 4 would be -2. Now I want to keep track of the fact that I have an OR problem here. So 3m plus 1 is greater than or equal to 10. I'm actually going to use another color so you can see I'm doing something different here. So I have a plus 1. I need to minus 1 from both sides of the inequality. That'll make that cancel. I'll bring down 3m is greater than or equal to, and then 10 minus 1 makes 9. I have to divide both sides of my inequality by 3, and that gives me, m is greater than or equal to 3. Now, whenever I have an OR equation, I need to put the pieces together. And in fact, I'm going to switch it to one color. So m is less than or equal to -2, or m is greater than or equal to 3. And there aren't any numbers that make this true at the same time. There's no number that's smaller than -2 and at the same time bigger than 3. But or just has to be true for one of the two parts at least. And so, so we're okay on this. We'll use a solid dot for the -2. And less than or equal to -2 goes in this direction. We'll use, we have a solid dot for this one as well, for the 3, since it included the equal bar. And greater than or equal to 3 will go in this direction. And I'll go ahead and put the other colors up there so you can see. So this was the blue section. This was the green section for you to see. And so that statement, this statement right here, is the solution to the compound inequality, because at least either this side's true or this side's true. All right, and then number 4, we have, again, an OR problem. So we'll solve each part separately. I'm going to start with 4k minus 7. I'll need to undo -7 by adding 7. And so that'll be 4k, this will cancel, is less than 32. And then I have to get k by itself. I'll divide to undo that multiplication. K is less than 8. So there's one piece of this compound inequality. Now, I'll switch colors for this one. I have 12 minus 9k greater than or equal to 30. I want to be careful that I am moving a like term. So I want a minus 12 to both sides of the inequality. And so my 12s cancel. Now my 9 is negative. I'll need to remember that. Negative 9k greater than or equal to, and then 30 minus 12 is 18. Now I'm getting ready to divide by a negative. So as we talked about at the beginning of these notes, when you divide by a negative, you have to remember to, whoops, I almost didn't do it. You need to reverse your inequality. So k is less than or equal to negative 2. All right, now let's see what happens with this graph. I'm a little concerned because I see both of these are less thans. So I'm actually going to graph up above the number line first just to see what happens. So I'll start with the k is less than 8. And that's going to be an open circle on the 8. Whoops, I thought I had changed colors. An open circle on the 8, less than would go in the direction of 0. Okay? And then k is less than or equal to negative 2. So that would be a solid dot for the negative 2. Less than or equal to would actually still go in this direction. Now, I need to make a decision about my final graph, because my final graph, I don't want to have two arrows going in the same direction. So I will remember that on an OR graph, it has to be that at least one part is true. So actually, from 8 on down, at least one part is true. So for this graph, when you notice these inequality symbols going in the same direction, you may want to graph above, because your final graph, which I'll do in black here, is where for the OR problems, at least one part is true. And so that would be everything from the open circle on the 8 on down through the rest of the number line. So this actually is my solution picture, and then my actual solution that I would need to write, or if you were typing this into Alex, your solution is k is less than 8, because if you have a number less than 8, it will automatically, if you have a number less than or equal to negative 2, it will automatically be less than 8. And so this is just kind of absorbed into this first condition that k is less than 8. All right, and then finally we'll move on to our last two examples, 5 and 6. And you'll notice that your inequalities look like they are the same, but they're connected by two different words. So we have and for our first one, we have or for our second one. So let's see what happens. We will add 5 to both sides of the inequality. That gives us 2b is greater than 20, and then divide by 2 on both sides, and we get b is greater than 10. All right, then this one we'll subtract 3 from both sides of the inequality, and that'll cancel. That'll give us b is less than, and 3 minus 3, which is 0. I'm going to fix that less than just a little bit. So b is less than 0. All right, so let's see if we can think of numbers that would be less than 0 and greater than 10. So let's think about that. Numbers that are less than 0, that would be like in the negatives. And then greater than 10, let me bring this back down. Greater than 10, those would be numbers up here, like 11 and 12. And in this situation, to have numbers that are greater than 10 and numbers that are less than 0, there is no overlap. Now, I'm going to show you that graphing above. Greater than 10, less than 0. It's just not working. I'm also going to show you if we try to put it together. So 0, and that's our smaller number. B is our variable. 10's our larger number. We're supposed to be using these less than signs, but these are always supposed to point to what they were pointing to before. Well, this symbol is not pointing to the 10 like it was before. So that symbol is not right. And yet that's the one we're supposed to use. And likewise, this symbol is supposed to be pointing to the B, which it isn't. So that's not right. And so we can't write it in the way that we're supposed to be able to combine these. So on an AND problem, where it's supposed to be an intersection, both parts are supposed to be true. If you get this kind of graph, then actually you have no solution. There are no numbers that are bigger than 10 and less than 0 at the same time. Now, since we went through the process of solving and we have the same numbers, we don't need to show all that again. Let's skip here to our conclusion. B is greater than 10, not equal to, just greater than. So B is greater than 10, or B is less than 0. So remember, it was the same problem. I'm just changing the wording. Well, that is possible because only one part has to be true. So B is greater than 10, or B is less than 0. And so for an or statement, that actually is your solution to this. Not an and, that would be a no solution, but or, this would be your solution. So this is your lesson on compound inequalities. Remember to be sure to use your notes as you're doing your homework. And of course, if you have any questions, your teachers are very happy to help you. Please ask questions, and good luck.